All right, before we get into today's notes, we've got a warm-up that's a bit of a review, or should be, plotting points in a coordinate plane. So we are going to plot the point, and then we are also going to change the point, x plus 2, y minus 1, and plot that point in the same plane. So first of all, how do I get to the point 0, 1?
Over 0 up 1.
Good. We don't go left or right, but we do go up 1. Then if I were to change that point by this rule, x plus 2, y minus 1, what would that new point be?
2, 0.
Good. 2, 0. So we took the x coordinate, added 2, y coordinate, subtracted 1. How do I get to that point?
Go right.
And then?
Over. That's it. Over 0.
Good. Right 2, and then that's it. We don't move up or down. Okay, so if you wanted to put little number 1s by those, or we could label these as like A, B, and C, you could do that. I'm probably just going to switch colors. It's a little harder for you to do. All right, on number 2, where is the point -3, -2?
No, to the down 3 and down.
Good. Left 3, down 2. 1, 2, 3, down 2. And then if I were to change that point, x plus 2, y minus 1, what does it become?
-1 and -3.
Good. -1, -3. How do I get to that point?
Down 1.
Oh, careful. Which way?
Left 1 down 3.
Left 1, down 3. We go left or right by the x coordinate, up or down by the y coordinate. Okay, next up, we've got the point 1, 4. Where is that?
Right way
Right 1, and then where?
up 1.
Good. And if we change it, what does it become? Nope. 3 and 3. Not a negative, it's just 4 minus 1. 4 minus 1 would be 3. Are we all okay with 3, 3? How do we get to that point? Right 3, up 3. And last, we've got the point -2, -1. Left 2, down 1. And then if we change it, 0, -2. How do we get there? Good. Okay. So all of these higher points were our original points, and then they all moved. And it should be apparent from this graph that they all moved the same way. All right? They all went down 1 and then over to the right 2, or right 2 and down 1, which should make sense based on the rule that they gave us. But we just shifted all the points over and down a little bit. Questions on the warm-ups? Okay, so even though that was really kind of a review from algebra that gets into what we're doing today, we are going to be talking about translations. Our objective is to identify and use translations. Now, it might seem funny that we just took a test on chapter 4 and now we're back in section 3.7. The reason for that is that we took a few sections from various chapters and put them into a separate unit of their own. So all of these things that we're talking about this week are going to be related to each other, even though they're all from different chapters. All right, so this lesson is titled Translations, but first we're going to talk about transformation. A transformation is an operation that maps or moves a figure onto a new figure. So that should be part of your first fill in the blank. Transformation is an operation that maps or moves a figure onto a new figure. But there are multiple ways we can transform a figure. We can flip it, we can turn it, and we can shrink or enlarge it. We will learn about these transformations in these following lessons. Okay, did we get all the different ways we can transform a figure? Flip, turn, shrink, enlarge. Those are different ones that we'll look at later this week. Today we're talking about translations. A translation is a transformation in which the image is created by sliding the original figure. When you hear translation, think slide. We're not turning it, flipping it. It's not changing size. We are just sliding the object somehow. Up, down, left, right. The new figure after a transformation is called the image. So the image is the new figure. I'm assuming the next slide's going to tell us. Oh, no, it doesn't. So the pre-image, or I'll go by what your notes say. The original figure is called the pre-image. Thought that'd be on its own slide. So the original figure is called the pre-image. I know we're not eating in here, right? Because that's against the rules on the syllabus. Decide whether the red figure is a translation of the blue figure. What do we think about number 1? Did that figure just slide? Or did it turn, shrink, enlarge, do something else? It just slid. It's a slide. It's a translation. So this one we would say yes. It is a translation. What about number 2?
No.
Why not?
Because
it turned. So this one is no. You could say it turned or rotated because that black line moved. What about number 3? No, it shrank or changed size. We'll just put shrink. If it changes size, turns, or flips, it is not considered a translation. Questions, concerns about those? Again, if you didn't get the pictures drawn for it, it's no big deal. You got pictures on your next set of examples. Are we ready for those? Some people appear to be. Some are still on weekend time. All right, do we think number 1 is a translation?
No.
Why not?
It
It flipped. So this one is no because it flipped. What about number 2? Why not? It turned and it also stretched or changed size or shape.
Yeah.
So turned and stretched or just turned. Either way, it's a no. What about number 3? Yes, all they did was slide it over. So that is a translation. Questions, concerns? Translations should be pretty straightforward. Bless you. Prime notation. Whenever you see the points A, B, C, etc., and points A prime, B prime, C prime, the points with the little tick mark, we call them primes, are the points of the image or the new points. As you might have noticed as I was reading that, we read the A with the little apostrophe, tick mark, whatever you want to call it, as A prime. That tick mark is not an exponent. It just means the new A point. So the original figure is going to be listed with things like A, B, and C. And the new ones will have a prime. So the original would be A. The new is going to be A prime. Questions, concerns about prime notation? Okay. Then let's move into describing translations. So before we fill in the blanks, let's just look at this. Which segment is the original and which is the image or the new segment? So is the original segment the solid line or the dashed line? The solid line. So the original is the solid line, and the new one, or the image, is the... If it's not the solid one, it would be the dotted line or dashed line. Start by looking at point A. How does point A get to point A prime? Well, this slide tells us. It moves left 3 units and up 5 units. So if we start at point A, if we go left 3 units, 1, 2, 3, and then up 5 units, 1, 2, 3, 4, 5, we get to A prime. So A to A prime, left 3 units, up 5 units. Assuming that we are correct, the same movement should be true for point B. So we're just shifting everything. It should all shift the same amount. So left 3 units, 1, 2, 3, and up 5. 1, 2, 3, 4, 5. It worked. That must be how this is translated. Questions about that example? Okay. Let's see if the next... Nope, it doesn't. So let's go back to the front and let's work on filling in those blanks together real quick. So to describe a translation, I'll just blank this out. To describe a translation, start by looking at how a point gets from its original position to its new position. The same description should be true for all of the points, which we just saw that in that other example.
Can you go back to this?
Yeah. Do we get those blanks filled in at the bottom of the front page? Okay. We'll move on. Boop. So this was that last paragraph there. Okay. Let's move on and talk about describing these translations. So we pick a point to start with. Which point do you want to start with? D. Sure. You need to pick a point from your original figure, which would be the one without the primes. So D is a valid choice. We want to know what it takes to get from D to where? To the D prime. So I would start with left or right. Which way are we moving?
Right.
Left 3, down 4.
Right.
If I start at point D and I go to the left, I'm not getting closer to D prime.
Right.
Right,
Down
3. And down how many?
4.
4. Now, if I'm correct, then the same thing should work going from C to C prime. So right. 1, 2, 3, down, 1, 2, 3, 4. It worked, so I must be correct. You don't necessarily have to check it every time, but it might be useful just to make sure you didn't make a mistake. On number 5, what point do you want to focus on? X, sure. We want to know what it takes to get from X to where? X prime. So, left or right? How many?
5.
And then?
Down 2.
Down 2. Okay, so we could choose another point like Z to check ourselves. We go left 5, down 2. That worked to get from Z to Z prime. We could check it another time with Y if we needed to, but I don't think that's necessary. Questions about describing translations? Make sure you start at the original figure, meaning the plain letters, and you work your way towards the image or the one that has the prime on it. Okay. So coordinate notation means that we are going to, instead of using the words right, left, up, and down, we're going to instead talk about the X or Y values. So we've got a few questions to answer. When we move right, which value is changing, X or Y? Careful, which axis goes left and right? Your x-axis. So if you're going right, you're changing your x coordinate. If you go left, you're changing your x still. Side to side is always x. So left and right, side to side, that's your x-axis. Up and down is your y-axis. So if we're moving up or down, we're changing y. So if you need to draw your little axes to remember which is which, you can. Your x-axis goes left to right. Your y-axis goes up and down. Questions, concerns before we get to the next slide? Okay. When you move right, you are adding to the X value. When you move left, you are subtracting from the X value. When you move up, you are adding to the Y value. When you move down, you are subtracting from the Y value. That goes back to our warm-up. That's basically the same idea that we saw there. We were adding to our X or moving our points right. We were subtracting from the Y, which moved our points down. Ready for the next slide? I heard a lot of flipping, so I'm assuming we're ready. Oh, describing in coordinate notation. I don't know why they didn't. Let's do that first. So in the following notation, x comma y goes to, or arrow, x plus 1, y plus 5. The x comma y represents the coordinates of the original figure. The arrow represents the slide. And the x plus 1, y plus 5 means we add 1 to the x value or slide it right, and add 5 to the y value or slide it up. So if the warm-up made sense to you, then this notation should not be very difficult. The x comma y arrow part is always going to stay the same. We always talk about our original coordinate as x comma y. And we always have an arrow to show that it slid. Bless you. Questions, concerns, need more time on these blanks? Okay. Then let's try to describe these with coordinate notation. Now we could describe them in words, that's what we did before, but these ones are asking for coordinate notation. So we know that we're going to start these off with an x comma y arrow. We are going to assume, they didn't tell us, but we're going to assume that the original is going to be the solid line and the image is the one with the dashed line. So they kind of showed us if you take this point and move it here. So take this point, I'll call it A, and move it over here to A prime. They kind of made it easy because they showed us our path to take. Are we moving to the left or the right? To the right, which means we are doing what to x? Good. Adding to x 7 units. Comma, what's happening to y? We're adding 2. We're going up, so we're adding 2. That's it. That's all that we had to do for coordinate notation. So if in words you're saying that you're moving right, that means x plus. If in words you're saying you're moving up, that's y plus. All right, on number 7, same deal. We start with an x comma y in parentheses with the arrow. This time, what's happening to my x? We're subtracting because we're moving left. So we subtract 4. What's happening to my y? Also subtracting 4 because we're moving down. Now, I know on all these examples we've seen so far, it's always been like plus plus or minus minus. You can have them mixed together. You could be moving to the left and moving up, or to the right and moving down. Questions about coordinate notation? Ready to keep going? Some of us have already moved on. All right, for the next section, you are just asked to match the description with its diagram. So, we start with A, and we move to A prime on letter A. It's up to you how you want to do this. I prefer to look at the diagrams and then match it to a description. Honestly, they made it pretty easy on us because all these numbers are different. So for letter A, how am I moving it? Left or right? To the right, so that eliminates number 9. To the right, how many? 3 units, which means that letter A should match up with number 8. And we could double check that. 3 units and then 2 up. Yep, that worked. Letter B, which way am I moving? Point B. 4 units right and then 2 down. So B matches with 7. That leaves letter C to go with 9. And we could double check ourselves that if we start at point C, to get to C prime, we go 2 units left, 3 units down. That works. Questions, concerns? Continuing on. Okay. Oh, this slideshow doesn't have your last examples. So let's add them in there. You've got the directions, you just don't have the points. So for example 6A, let's use the points 8, -4. 6B, we'll use the points -1, 0. And for C, we'll use the points 5, -5. So if we are given these points and they gave you a rule, we see the rule there in the directions. What was the rule? Or the change? X minus 2, comma, y plus 4. So if I apply that to point A, what's my new point? 6, 0. I agree. What about on point B?
-3, 4.
Good. And on point C? 3, -1. Okay, so that's a lot like what we were doing in our warm-ups. Just following a rule to identify what the new point would be. Now, if these were my notes, I would make sure I had down the original point and what the new point is. But that's just my opinion. Okay, number 7 lists out your rule and your points, right? We all read number 7? Down at the very, very bottom. Are we good with 6? Can I erase those? Okay. Let's bring it back. So on number 7, what's the rule that they gave us? X comma y goes to what? X plus 4, y minus 2. Okay. And they gave us X, Y, and Z. Where was point X? Two, 3. What about Y?
3, -4.
3, -4. And Z is at -3, -5. So this is just like the last one. They're just using prime notation. So X prime would be where? 6, 1. Y prime would be where? 7, -6. And Z prime would be 1, what? Oh yeah, that's 5 is not negative. You're correct. 1, 3. Questions about using prime notation, about describing translations, identifying them? Translations, in my opinion, are the easiest transformation because they just kind of make sense. It's easy for us to visualize it. It's easy for us to describe it. The other transformations that we're learning this week, they have rules, but they're just a little trickier to remember.